So continuing with the topic on chemical equation, we are going to do this. This video is going to focus on empirical and molecular formula. You'll be given the percentages of the elements and you have to calculate the empirical formula. And it also has questions in which the combustion data is given, and from that you have to find out the elemental composition or the percentage and then calculate the empirical formula. So let's just, but this contains only the simplest of the questions. So let's go ahead and learn some of the questions given in this video. The first question, calculate the empirical formula of 100 gram of a compound. It has 82.4 grams of nitrogen and 17.6 grams of hydrogen. So to proceed first, just write down what is given. Write down in a column element nitrogen and hydrogen. Next, write down the masses given 82.4 and 17.6. Then write down the atomic mass. So the next step is to calculate the mole of these elements. Since we know mole is equal to mass over atomic mass, calculate the number of moles by dividing the masses given there by the atomic masses. And I get the moles. Once I get the moles, 5.88 and 17.4, the next step is we calculate the mole ratio. We divide by the smallest mole all the moles. For example, here the smallest mole is 5.88. So divide 5.88 by 5.88 and 17.4 also divided by 5.88. And I get the mole ratio as 1 and 3. So that means I have 1 nitrogen and 3 hydrogen. So therefore combine it together and the empirical formula of the compound given is NH3. The second one, calculate the empirical formula of a compound. Now it has 52.17% carbon, 13.04% hydrogen, and it also has oxygen. So as always, write down the elements given, carbon, hydrogen, oxygen. Then write down the percentages given to it. And write down the atomic masses also. You can get the atomic masses from the literature. Then calculate the moles by dividing the percentage by the atomic mass. And in the previous question, percentage was not given, but the grams was given. Since the total grams comes to be 100, total percentage also comes to 100, we can just consider these percentages as grams. That's why to calculate the moles, just divided the percentage by the atomic mass, I get the moles. So once I get the moles, calculate the mole ratio. The smallest number over here is 2.17. So divide all the numbers by 2.17 and I get the mole ratio as 261 for carbon, hydrogen, oxygen. That means we have 2 carbons, 6 hydrogen and 1 oxygen. And hence the empirical formula is C2H6O. Question number 3. Calculate the molecular formula of a compound. It has 40% carbon, 6.66% hydrogen and the rest oxygen. The molar mass of the compound is given as 60.02 grams per mole. So this is a question in which you have to find the molecular formula and not the empirical formula. So as always, first let's calculate the empirical formula. Write down the element, its percentage, the atomic mass, then calculate the number of moles and then calculate the mole ratios. So when I calculate the mole ratios, I get, we have 1 carbon, and then number of hydrogens we have is 2 and the number of oxygen is 1. So that means if I have to write the empirical formula, it will be CH2O. So putting all the carbon, hydrogen and the oxygen together. So now in this case, since they have asked you to calculate the molecular formula, we need to go further. So in order to calculate the molecular formula, the first thing we do is to calculate the empirical formula mass. And the empirical formula mass comes as 30.00 grams per mole. After calculating it, we calculate something called as N, which is calculated by dividing the molar mass by the empirical formula mass. And doing so, I get the value of N equal to 2. And to get the molecular formula, we multiply the empirical formula by this value of N. Since the empirical formula was CH2O, multiply it by 2 and the molecular formula comes as C2H4O2. So this question makes it clear to you that empirical formula is a least ratio an element exists in a compound. But in case of a molecular formula, the ratio is a multiple of the empirical formula. Now it's a combustion question. Combustion of 1.43 gram of a compound produces 2.09 gram of carbon dioxide and 0.78 gram of water. Calculate the molecular formula of a compound. The molar mass of the compound is also given to you. So in this case, the amount of carbon or the oxygen or hydrogen is not given to you, but only the combustion data is given. So whatever value you get for carbon dioxide, it can be used to calculate the amount of carbon, and the whatever value you get for water is used to calculate for hydrogen. And then we add up. If it adds up to the mass of the compound, then it's fine. If it is less than the mass of the compound, then it means that this compound has oxygen also. So combustion data, carbon dioxide gives carbon and water gives hydrogen. So let us calculate the amount of carbon using the grams of carbon dioxide. So you have 2.09 grams of carbon dioxide. So convert the grams of carbon dioxide into moles of carbon dioxide. And in 1 mole of carbon dioxide, you know that we have 1 mole carbon. So once you get the moles of carbon, I can convert it into grams of carbon just by multiplying it by the atomic mass of carbon. And doing this calculation, I get the grams of carbon. Now to get the grams of hydrogen, use the mass of water. Water is 0.78, so convert it into moles of water. Then in every mole of water, I have 2 moles of hydrogen. And I get the grams of hydrogen as 0.09 grams. Now add up the 2 and I can see that it doesn't add up to 1.43. So subtract it from 1.43 and I get the mass of oxygen as 0.77. So you can ask me a question why I cannot get the value of oxygen from carbon dioxide and water. That result is not accurate because any oxygen present, it has got converted into carbon dioxide, into water, and some of them could have been lost also. So using the combustion data, oxygen is always calculated after calculating the mass of carbon and hydrogen and subtracting it from the total mass of compound. So now we have to calculate the molecular formula. So we have the mass of carbon, we have the mass of hydrogen, we have mass of oxygen. So let's proceed further and calculate the empirical formula. Continuing from the previous page, we know the elements are carbon, hydrogen, oxygen, and we also know their masses. And then once you know the masses, we know put in the atomic mass. So after you put in the atomic mass, divide the mass by the atomic mass to get the moles. And the next step is to get the mole ratio, and 0.048 is the smallest mole, so divide all of them by 0.048, and then that means that we have 1 carbon and we have 2 hydrogens and the number of oxygen we have is 1. And combining all these two together, we can get the empirical formula of the compound. The empirical formula will be CH2O. Here, since we have to calculate the molecular formula, calculate the empirical formula mass of this compound, and that comes as 30.0 grams per mole. So after this, we need to calculate the value of N, which is molar mass divided by empirical formula mass, and that comes as 6. Once you get the value of N, the molecular formula is obtained by multiplying the empirical formula by this number, that is 6. And in doing so, the molecular formula comes as C6H12O6. So this is one example in which the mass of the substance is not given. You have to calculate it from the combustion data, and we saw it how to calculate it in the previous page. So one more combustion question. Here we have 1.85 gram of the compound, and it gives me 4.07 grams carbon dioxide, 2.16 gram water. You have to calculate the molecular formula. The molar mass of the compound is given as 60.0 grams per mole. So similarly, using the value for carbon dioxide, calculate the grams of carbon as we did in the previous question. Then using the values for water, calculate the mass of hydrogen. And to get the mass of oxygen, add up the two and subtract it from the mass of the compound. And then now we have the mass of all the three elements. And let's just proceed further and calculate the empirical formula. So we already have the values of the elements. The elements we have is carbon, hydrogen and oxygen. From the previous page, put in the masses there. And the next step is, as you all know, put in the atomic mass. Once we have the atomic mass, calculate the moles by dividing the mass by the atomic mass. And then get the mole ratio by dividing by the least number of mole, that is 0.031. So when I do that, this I get 3 carbons and 8 hydrogen, and the number of oxygen I have is 1. So with this as a base, write down the empirical formula, and the empirical formula is C3H8O. So since we have to calculate the molecular formula, the first step is we will calculate the empirical formula mass, and that comes as 60.0 grams per mole. And since the molecular form mass is given, molar mass is given, calculate the value of N, and N comes as 1. And the molecular formula is calculated by multiplying N and the empirical formula, and therefore 1 times C3H8O, and I get the molecular formula also as C3H8O.